The travel rule only works if your data moves as smoothly as your crypto. In this module, we'll turn abstract requirements into a concrete NovaX data pipeline. How information is captured, validated, transmitted, and used across systems and teams. For NovaX, the travel rule isn't just a legal question, it's an engineering puzzle. They need to answer three things at high speed for every qualifying transfer. First, identity. Is the destination really another VASP, and who is the customer behind it? Second, protocol. Which messaging standard and provider can actually talk to that counterparty? Third, routing and timing. When and how is the data sent so the transaction isn't slowed or blocked? Real success means doing all of this automatically, at scale. Before NovaX can comply at scale, it has to decide how to connect to other VASPs. Building everything in-house gives maximum control and flexibility, but it's slow, expensive, and hard to scale, because every new counterparty needs custom work. Buying into a vendor network is quick and highly interoperable, but you accept vendor lock-in and per-transaction fees. A hybrid model adds an internal orchestration layer on top of multiple networks, trading some speed and simplicity for broader reach and strategic control. To make the travel rule work globally, VASPs first have to agree on what the payload looks like, before worrying about which network carries it. That's the role of IVMS101. Think of it as a universal shipping manifest. Every originator and beneficiary is described using the same fields in the same structure. NovaX's system maps its internal customer data into this schema, wraps it in encryption, and sends it on. The receiving VASP can then automatically plug that standardized JSON into screening and monitoring tools without custom integrations each time. When NovaX applies the travel rule, the first challenge is simple to state but hard to execute. What exactly is on the other end of this withdrawal? They answer it by triangulating three signals. Blockchain analytics shows whether the address behaves like an exchange or a lone wallet. The customer's own declaration provides a second clue. Travel rule directories then confirm whether that named exchange is actually reachable over a trusted network. Only when those three align can NovaX confidently treat it as a verified VASP. Otherwise, it's handled as an unhosted wallet. The next key design choice is timing. Do you send travel rule data before the blockchain transfer or after it? In the conservative model, NovaX only broadcasts the on-chain transaction once the counterparty VASP has received and accepted the IVMS101 data. That slows the user experience slightly, but it keeps settlement and compliance aligned. The low-friction approach lets funds move first and pushes compliance data later. That feels smoother for users, but it can leave NovaX exposed if the counterparty ultimately rejects the transfer. Every withdrawal that isn't perfectly mapped to a compliant VASP becomes a destination risk decision. At the low-risk end, a VASP to VASP transfer with full IVMS101 data is largely automated. Standard screening, minimal friction. Unhosted wallets are different. NovaX relies on the customer's declaration and proof of control, adds analytics, and tightens thresholds. The hardest case is the non-compliant or legacy VASP. Data is patchy, reviews are manual, limits are strict, and sometimes NovaX simply can't allow the relationship. Unhosted wallet withdrawals are where the travel rule and AML really intersect. You can picture NovaX using a risk thermometer for every self-custody withdrawal. At the bottom, low value, a clean wallet history, and a low-risk customer. Those can be auto-approved, maybe with the wallet quietly added to a watch list. As the thermometer rises, the workflow changes. The system holds the transfer, asks the user why they're sending funds and to whom, then routes it to compliance for blockchain analytics review and a final approve or reject decision. Sometimes NovaX can see that the destination is clearly a VASP, but there's no working travel rule channel. That's a classic non-responsive counterparty problem. The key is to avoid reflexively blocking everything or waving it all through. First, the system parks those transfers in a quarantine state. Then humans step in. The compliance team checks licensing, jurisdiction, prior dealings, and open source intelligence. Based on that, NovaX either proceeds under tighter monitoring and outreach, or rejects the transfer and flags that VASP as too risky. Now think of a travel rule compliant withdrawal as one smooth workflow. The user just hits withdraw. Behind the scenes, the rules engine becomes the brain. It checks KYC records for who the customer is and blockchain analytics for where the funds are going. If everything fits policy, data is converted into the right standard, then routed over a secure messaging network to the counterparty VASP. If something looks off, the transfer drops into an exception queue, where human analysts review, document, and decide. To make travel rule compliance sustainable, NovaX has to think like an architect, not a firefighter. Designed for interoperability, so you can switch providers and plug into new networks without rebuilding everything. Treat identity as a composite signal, UX inputs, KYT scores, blockchain analytics, and historical behavior together. For edge cases like unhosted wallets, predefine what's acceptable, what needs review, and what you'll block. And finally, weave these controls directly into product and engineering flows, rather than layering them on later.